Now we're going to look at a situation where we're using the mole ratio in conjunction with masses from the periodic table. So let's back up a minute. We measure in mass. We can't measure in moles, but the relationships in the balanced equation, they're in moles. So what we need to be able to do is either convert from grams to moles, so then we can do the mole ratio, or we need to be able to convert from the mole ratio into grams. So let's say moles to grams of a substance. So that's what we'll be looking at right now. What we have to do is use the conversion factor. 1 mole of anything is equal to its mass from the periodic table in grams. We will be using 4 sig figs from the periodic table, always. So just let's remember, if you have 24.02 grams of carbon, you can convert that to moles. We're not going to be converting to atoms. The way we do that is put the given here, like always. We put the mass from the periodic table here, and that is equal to 1 mole. We call it the molar mass, so the molar mass of carbon is 12.01 grams per mole, or 12.01 grams in 1 mole. So we're just kind of using that, applying it a little differently up here. As far as you're concerned, what really matters though is that we take the mass from the periodic table and we use it equal to 1 mole, and that's how we're going to get into moles, or go from moles to grams if we flip that. So let's see how we'll do this. In this example, we'll go from moles of one thing, so X, to mass of something else, Y, and in between we'll use the mole ratio. It's that thing that binds it all together. So first, 7.2 moles of aluminum oxide. That's given. How many grams of oxygen are formed? That's what we're looking for. So let's start. 7.2 moles of aluminum oxide. Well, I can't go straight to oxygen grams. I actually have to figure out how many moles that is. So from the balanced equation, 2 moles aluminum oxide, 3 moles oxygen. So this is the mole ratio. Well, now if I cancel things, so moles of this, moles of that, I'm left with moles of oxygen. Well, it wants grams of oxygen. So this is where I'm going to use the molar mass from the periodic table. So let's continue. Now, I know that 1 mole of O2 is 32.00 grams of O2. Please round correctly. 15.999 does not round to 15.99. It rounds to 16.00. And I'm fine with you just saying 16, and in this case 32. Okay, so anyway, this is your conversion factor. 1 mole of O2, 32 grams of O2. You have to determine what goes on the bottom and what goes on the top. You want the moles of O2 to cancel, so you're going to want to put 1 mole O2 on the bottom and 32 grams of O2 on top. Okay, so we've got it all set up. Let's make sure everything's going to cancel right. So moles of O2, and what we're left with is grams of O2, and that's what we wanted, grams of O2. Now, mathematically, you're going to multiply 7.2 times 3 times 32, and then you're going to divide by 2. And when you do that, you get 34, hold on, how about 345.6 grams of O2. Sig figs wise, you should write 350 grams of O2. Most of the time I will use 3 sig figs in my given. So let's look at another one. So we're starting with moles of one thing and going to mass of something else. When sodium azide is activated in air, this is sodium azide, nitrogen gas and sodium are produced. Here's the balanced equation. If you have 0.5 moles of sodium azide, what mass of nitrogen will be produced? We get to ignore the sodium right here, the elemental sodium, because it's not involved. We can only compare two things at one time. So let's start. We have 0.5 moles of sodium azide. Well, I've got moles of sodium azide. Can I go ahead and go into moles of nitrogen? The answer is yes. So 2 moles of sodium azide and 3 moles of nitrogen. Okay, so this is the mole ratio again. It's the converter for us. It converts from one thing in the balanced equation to something else. And then we need to go into grams of nitrogen because that's what we asked for. So 1 mole of nitrogen. I look at the periodic table. 1 nitrogen is 14.01 grams per mole in 1 mole. So 2 nitrogens are 28.02 grams. So let's make sure we did this correctly and cancel. Moles of sodium azide, moles of sodium azide. They cancel. Moles of N2, moles of N2. And we are left with the unit we want. And the answer to this, according to my calculator, is 21.015 grams of nitrogen. Based on sig figs, the answer is 20 grams of nitrogen. Remember, sig figs, we're only counting the starting. I probably will do 3 sig figs on test, so you could expect 21.0 grams of nitrogen. Oops, I forgot my 2. Okay, so this time, let's start with mass of something, X maybe, and let's go ahead and find the moles of Y. The balanced equation here, and it says how many moles of ammonia, NH3, so we're looking for moles of ammonia, are required to produce 30 grams of hydrogen. Notice that you don't have to start with reactants and solve just for products. You can start with products and solve for reactants. This would be useful to someone who needed 30 grams of hydrogen and wanted to know how much ammonia they needed to start with. So, the given. Let's go ahead and make that 3 sig figs to make our lives easier. So, 30 grams of hydrogen. Well, last problem, we went straight to the mole ratio. But this time, we have grams of something. We can't cancel grams and moles, so we need to use a conversion factor to take it from grams into moles. Periodic table says that 1 hydrogen is 1.008 grams per mole. Okay, so that means that 2.016 grams is H2's molar mass, and that's in 1 mole. Okay. Now, if I look at it, my grams are gone, and it's grams of hydrogen. It's very important that you write the hydrogen. It's very important that you cross it out. These are part of the unit. So now I have moles of hydrogen, and I want to go to moles of ammonia. Well, that's the mole ratio. So moles of hydrogen. So there's 3 moles of hydrogen for every 2 moles of ammonia. Before I pick up the calculator, I'm going to go ahead and make sure my moles cross, and they do. So now it's time to calculate. So the answer is 9.92 moles of ammonia. So let's examine this. I first used the molar mass to convert from grams into moles of hydrogen. I had to in order to use the mole ratio. And I got the mole ratio from the balanced equation, and I got the molar mass from the periodic table. Let's do one more example. So, a very long one. If you begin with 250 grams of sodium chloride, so we've got 250 grams of sodium chloride, and we'll go ahead and make that 3 sig figs, so put a decimal behind the 0. How many moles of chlorine gas? We want to know. So the first thing we have to do is convert 250 grams of salt, NaCl, into moles of NaCl. So from the periodic table, I know that Na is 22.99 and that chlorine is 35.45. So that means that 58.44 grams per mole for sodium chloride. So let's use that. 58.44 grams of sodium chloride in 1 mole of sodium chloride. If I stopped there, I'd be in moles of sodium chloride, but that's not what I wanted. I wanted to know moles of chlorine gas. So, time to convert from one to the other using the balanced equation. 2 moles sodium chloride, 1 mole chlorine gas. And that answer is 2.14 moles of chlorine gas.